All right. So now that we've identified that this species is the limiting reactant, this amount has nothing to do with it. This amount was how we figured out that species was the limiting reactant. But now that we know that this is the limiting reactant, to find the theoretical yield, we have to go and use the given amount right here of that limiting reactant. So we identified this species as the limiting reactant. Now we're going to start with this given amount of that species. Okay? All right, so this solution map is still going to work for us. Okay, we're going to use this same solution process. But we're going to start with this given amount of limiting reactants. We're going to start with 2.00 grams of potassium sulfate. So the first thing we need to do is determine the moles of that starting reactant. And we've already done a calculation for the molar mass of that. So we don't have to do it again. We can use that molar mass right there to write this conversion unit that we need. Okay? So we need the molar mass of that starting reactant to find the moles of that starting reactant. The molar mass is right here. Has the equality statement in there. So all we have to do is put it in. Okay? We want to match the units and species that we're starting with what's on the bottom here. So we need grams of K2SO4. Down here, here's the number that goes along with it. 174.259 grams of that. The other side of the equality statement, you have to write, every time you do molar mass, is 1 mole of K2SO4, so we're going to put that on the top. And we're ready to do that math. Cancel the units, James.
Yep.
And do the division. Please get your calculator out and practice with me. The more you practice, the better you get at it. The more likely you are to have the right answer on a test. Please practice with me. Okay? You can't get 0.11477169? We're determining the theoretical yield. We're determining the amount of theoretical yield. All right, now I need to put moles of K2SO4 on here because that's the species I have left, and that's the units I have left. Need to round it off. This is a measured number, a calculated number. These two ones are counting numbers. These are the only two numbers here, the measured number and calculated number, are the only ones I consider when figuring out how many significant digits I need in a multiplication division problem. Leading zeros are not significant. Underline everything after the first three digits. Show an arrow to say we're rounding off. And write 0.014, let me do that again, 0.0115 moles K2SO4. Okay? So looking at our solution map up here, or our math solution map, okay, we've gotten from mass of the starting reactant through molar mass to find the moles of the starting reactant. Now we're ready to go from moles of the starting reactant, moles of the ending reactant. Now this is a little bit different, not much different, same process as far as the math is concerned. We're going to start with this amount right here and make that a starting amount, K2SO4, put it over 1. We need a conversion unit. Every conversion, well, not a conversion unit, but a conversion factor here. This is going to be a molar ratio. We're going to have moles on the bottom because we've got to match the units on the bottom of this conversion, and the species have to match, K2SO4. Okay? But now this is a molar ratio. This is where we're going to go from one species to another species. We need to know what species do I need to go to. Okay, well in this case, we're looking for a product. We're no longer looking for another reactant. We're looking for a product. So we're going to go from our limiting reactant. So we've identified this species here as the limiting reactant. And like in your lab, we want to find out how much solid is produced. In your lab, you produce a solid. We're looking for how much solid is produced. So we want to go to moles of calcium sulfate. And what is the molar ratio between potassium sulfate and calcium sulfate? 1 to 1. Wow, that math is easy too, isn't it? 0.0115. Now, it isn't always that easy, but this time it is. You got lucky here. K2SO4. It's not that easy in your lab work, by the way. There's some coefficients to deal with.
Do you always put the first one or the one that's a solid?
Well, and whatever you're looking for. In this case, we're going to look for the solid. Okay, I'm trying to give you a problem that imitates what you did in your lab. Okay? Hello? Go ahead and tell her. Sure. Okay, Bailey, when you leave here, go buy attendance and get a pass, okay? You hear me, Bailey? Go buy attendance and get a pass when you leave this room, okay? All right. Sure. All right. Now, so what we did originally was just to find the two solutions that were mixed together. So what I'm going to do is add another step to this problem. Okay? What I'm going to add to this problem is if 1.00 grams of solid is collected at the end, what is the percent yield? Okay? That's what you did in the lab. You collected a solid at the end, and what we're going to do is show you how to determine a percentage yield. All right? You with me so far? Okay. So we're about to run out of class time, so let me tell you how to finish this problem. And it's not hard. You're simply going to go from the moles of this ending amount, the solid we're looking for, and find the mass of that ending amount. This step right here. Got that? Once you have the mass of that ending reactant, you're going to calculate a percent yield. Once you find this mass, that's your theoretical yield. Okay? That's your theoretical yield. This amount right here is your actual yield. So what you weighed out at the end in your lab was your actual yield. You're going to find your theoretical yield. You're going to take the actual yield and divide by the theoretical yield. Multiply by 100. And it's in your unit handout. Okay, the process is there. I know all of you can read, so go and read it. Follow the process in the unit handout. Calculate a percentage yield. That's your homework tonight. For your lab, calculate a percentage yield. Does everybody understand? Okay, yes. No, just the 1 gram of K2SO4, because that is a solid here. Divide by whatever amount you calculate at the end of all this math. Then times 100, give you a percent. No, this is moles. You still got to calculate the mass of that. We haven't finished the last step. There you go. You got it. Yes.